Okay, I'm going to briefly look over the notes and then I'm going to look at the worksheet. This is the linear and nonlinear scatter plot. So just to go over some of the vocabulary that you're going to see, a scatter plot is just data points on a graph. So we have seen so far when we look at graphs, we've just seen like straight lines, whether positive or negative. This is going to be just a bunch of data points. Not necessarily in a straight line, but they might make a trend. And so one of those trends we call linear. So that's when the scatter plot, when you look at it as a whole, when those dots kind of make a straight line pattern. So when you could draw a straight line through the pattern. Nonlinear is a scatter plot that's not going to make a straight line pattern. So that would be something like this second graph here. I can draw a straight line, but do all the points fall onto that line? No. And actually that would be nonlinear, but this graph right here would be more of no association. So that's when the dots are all over the place. There's not really a pattern. Oh, I didn't see this third one. This third graph would be an example of a non-linear scatter plot. Linear. Because it does have a pattern, it goes down and then it goes back up, but can we draw one single straight line through it? No. That's what would make that one non-linear. There's a trend, it decreases then increases. That would technically be a trend, but since there's no one straight line, that would be non-linear. Unlike this top one, where I can draw one straight line. And that's where the word linear would come in. Notes. Okay, so here's the worksheet. Looking at number 1, determine if the following scatter plots are linear, nonlinear, or if there's no association. So remember, linear means one straight line. So I'm going to write one straight line, or just one line. So on number 1, I've seen a lot of kids over the past couple days, they'll draw straight lines. That's true, but we're looking for one straight line. So in this case, it would be non-linear because technically there would be 2. And there is a trend, so there's an association. It's positive and then it turns negative. Number 2, same thing. You can kind of see a positive trend. They're all kind of going up, but is that a straight line, the line that I just created with those dots? No, it kind of curves. So that would also be a non-linear scatter plot. Then number 3, if I were to make a line through the majority of those points, it's pretty straight and all of the dots kind of fall along that same line, so that would mean that that is linear. 4, same thing. Is this linear, nonlinear, or no association? Number 5, the dots are everywhere. So even if I just randomly drew a straight line, the dots would still be everywhere. They wouldn't be surrounded, they wouldn't be on the line. They would still kind of be scattered about evenly. So this is going to have no association because there's not a trend. The dots don't all go up or down or across. They're everywhere, so there's no association on that one. Number 6, linear or nonlinear. Number 7. Number 8. And actually, that's not a good way to do it. If I did this, I drew a straight line. The dots do have a trend. They kind of all go downwards, but the line I would have to draw to go through most of the dots is not a straight one. Number 9. Ooh. I believe number 9 is nonlinear because it's not a straight line. Same thing on number 10. It's not a one straight line. Same thing on number 11. Look at what would happen if I traced those dots. Number 12. On number 13, this is kind of a star type question. First of all, think about if it's linear or nonlinear. And then look at the statements and see which is best supported by the scatter plot. F says this is a nonlinear association. Well, already that's not true because the points, they trended upwards in a positive pattern, and I could draw a straight line through them. So it is linear, so F would be out. G says there is a negative linear association. Linear is correct. Negative is not correct. Negative would mean that the graph or the lines went this way. H says there's no apparent association. J says there is a positive linear association. Solve the following equations. I'm going to go through number 14 because I've seen some kids struggle with these equations lately. So remember, we're going to box in our numbers with our variables. We're going to box in our regular numbers, including the signs that come right before them. So I'm going to move one of my plain numbers first. I'm going to move this smaller one so I don't have to have any negatives. And since it's got a plus sign in front of it, I'm going to do the opposite and subtract it. So minus 3.6 here, minus 3.6 over here. So 14.8 minus 3.6 is 11.2. And then bring everything else down. Plus 5.2m, and then 2.4m. And I'm going to go through and I'm going to rebox everything I have. Now I have to move, I can't move the 2.4 because it's by itself on that side of the equal sign. And I can't move the 11.2 because it doesn't have an m on it. I need something that can be combined with the 2.4. So I can only move this 5.2. Since it has a plus sign in front, I'm going to do the opposite to get rid of it. So subtract 5.2m. So that gives me 2.4 minus 5.2, and I get, I'm going to rewrite it. I guess I get right here. Negative 2.8m equals 11.2. And then our last step, since this right here is multiplication, I'm going to divide. 11.2 divided by negative 2.8. Nope, put that in wrong. Should be negative 4. 16 and 17, slope intercept form. Y equals mx plus b. First thing to find. Okay, so when we're finding the slope intercept form, y equals mx plus b, I would find b first because it's the y-intercept. It's kind of the easier thing to spot. And it's just where your line crosses the y-axis. So on this one, it's going to be 6, and it's a positive 6 since we're counting up from the origin from 0. So the plus b is going to be 6 plus 6. So to find the m, we need one more point at least. And I'm going to use this point. Okay, so then for the m, the slope, we are going to do our y2 minus y1 over x2 minus x1. So I'm going to use these 2 points. I'm going to use the y-intercept, which was at 0, 6, and this other point I made, which was at 2 and 4. So if we label those, use a different color, x and y, we'll say those are the ones, x and y and my 2's. And then plug it into the formula. So I've got y2 was 4 minus y1, which was 6, on top of x2, which was 2, minus x1, which was 0. So 4 minus 6 is negative 2. 2 minus 0 is positive 2. When we divide those, negative 2 divided by positive 2 is negative 1. So M is -1, and then you've got X. So all together it should look like that. -1x plus 6. Same thing on number 17. I'm going to go ahead and put a point here at the y-intercept. So that's at 0, -2. And I think that's a point. So that would be at 2, 2. Okay, so y equals mx plus b. Find your b and find your m by using that y, or by using the slope formula. 18, determine if the following problems are a function. Remember, if we are determining a function, we're only looking at x values, and we are looking to see if any of those numbers repeat. In this case, we've got -5, -6, -7, -8, -9. None of those numbers repeated. They were all different, so that means this is a function. If any of them repeat, then it's not a function. On number 19, if it's a graph, determining if it's a function, you're drawing a straight line anywhere on the picture. And if it crosses your line more than once, then it's not a function. So it doesn't cross our line more than once on this one, so it is a function. And then the last two determine if the following problems are proportional. So if it's a graph, it needs to go through 0, 0. And if it's an equation, it'll only have one number.